All right, so the final part of arithmetic lessons. So here we will work with fractions and decimals together. We will do some conversions, and also I will look at some past papers questions regarding this particular topic. Okay, so first of all, how do we convert fractions to decimals? Short answer, we just divide. So we just divide numerator by denominator. So that's it. That's the method basically. That's all you have to do is you just divide numerator by denominator. So let's just try to do it quickly. First of all, 1 over 2. So we just do what we do. 1 divided by 2. That's going to be equal to 0.5. All right. So 1 over 2 equals to 0.5 as a decimal. This one is very, very common. So you might as well memorize that 1/2 is 0.5 because you'll see it very, very often. So second, we have 2/3. So that's just 2 divided by 3. 2 divided by 3, 0, 6, 6, 6, 6, 6, 6. It's just going to go like this forever. So 2/3 would be equal to 0.6 recurring. So we will talk more about this. So this point on the top means, this small point means that 6 is repeating indefinitely. So many, many, many times. Sometimes it's written like this. One more way to write it is to write it like this. 666, and then there's 3 dots in the end. So that's one more way to write it. But again, this one is more, this is a recommended way, I would say, to write it. Okay, so next we have 1 and 1/5. 1 and 1/5. Here actually what we can do is we can say that 1 and 1 over 5 equals to 1 plus 1 over 5. This way we don't have to convert both parts, we can only convert the fraction part. So only this part can be converted to decimal. 1 over 5. Of course, 1 divided by 5 equals to 0.2. So we can say that's 1 plus 0.2 equals to 1.2. And finally, we have 2 and 6 over 7. 6 over 7. All right, so let's just work with this part. 6 divided by 7. So let's just do this quickly. 0. Then we have 60 divided by 7. It's going to be 8. Then we have 4 here. 40 divided by 7 is going to be equal to, what's it going to be, 5. 85. Then we have 50, 0.857. At some point, you can just leave it be probably. So I think 857, 3 decimal points is enough. It's going to be 2.857. Okay, just a small trick which you maybe already thought about. On your calculator there's a button which looks like this. Normally it looks like this. There's S, then there's a double-sided arrow, and then there's D. Okay, this is a very important button which allows you to convert fractions to decimals and decimals to fractions. So yeah, quite useful. 2 and 6 over 7, so let's write it. 2 and 6 over 7. Convert to decimal, 2.857, and more digits, right? This button is here, S to D, right? So it can be 20 over 7, or it can be 2.857142, repeating. That's it. So we can just use calculator for this. By the way, to write this kind of fraction, there's a button. So normal fraction can be written by using this button. So if you have a fraction like 3 over 4, you can use button like this. But if you have a fraction like 2 and 6 over 7, there's also a button which looks like this. Looks like this. Or maybe maybe it looks like this. So it's going to look like this. Like in my calculator, it looks like this. So A and B over C, something like that. So this button, you can use it to write mixed numbers. So you can use this button to do that. Okay, so that's it for fractions to decimals. Decimals to fractions is way more easy, I would say. Let's just keep it down, yeah. Okay, so 0.25 converted to a fraction is just going to be, converted to decimal. No, converted from decimal to the fraction. 25 over 100. It becomes 25 over 100. Again, can be simplified. It's going to become 1 over 4. So 0.25. 25. If you think about how you read this number, actually it's 25 hundredths. So when you write decimal, decimal is just a specific variation, I would say, a fraction. So it's easier to convert it this way. 0.125. So let's do this as well very quickly. 0.125 becomes 125 over 1000. So notice please that here it's over 100, here it's over 1000 because there is 3 digits after the point. So this placeholder, this is 1/10th, this is 100th, and this finally is 1000th, right? So keep in mind the placeholders. Okay. So this can be simplified, and it will become, if you simplify it, you can simplify a couple of times. I think you know by now how to simplify, but let's just do this quickly. It's going to be 25 over 200 can divided by 5. Becomes 5 over, what's it going to be, 40, which becomes a 1 over 8. 1 over 8. So that's the final answer. 3.95 converted to a fraction. Again, so why don't we just take this part, which is a fraction part. So 3, we just leave 3 alone, just keep it here. And 95, 0.95, we convert it to fraction, becomes 95 over 100. This will become 3 and 19 over 20. If we divide this fraction by 5 like this. And finally 0.007. So again, watch out, here the mistakes can be made. So let's just think about it. If it was here, it would be 7 over 10. If it was here, it would be 7 over 100. But because the 7 is here, it's 7 over 1000. So that's 7 over 1000. Please keep in mind how many digits after points you have to correctly choose whether it's over 1000 or 100 or something else. Again, this can be checked quite easily by using the same button on the calculator. So you can just type this here, 0.007. It's 7 over 1000. Again, this precious button, S to D, right? Fraction and a decimal. Just click a couple of times, play around with it, get comfortable with your calculator. You will need it a lot of times. Okay, so that's it for converting. Let's quickly, one more thing I almost forgot about, recurring decimals. So that's an interesting topic, recurring decimals. Let's try this. Normally it's quite simple, but there are some exceptions. So let's say, let me just quickly give you some examples. A number like this, so 0.444. I think I'm going to move this down, so I'm just going to quickly show you a little bit of theory in this. So a number like this, 0.44444, repeating, can be written as 0.4 with the point on top, with the dot. Which can be written as a fraction as 4 over 9. In the same manner, 2 repeating can be written as 2 over 9. And in the same manner, if you have 2 numbers repeating, so let's say it's 2, 3, 2 and 3 are repeating, which is equal to, if we would write it, would be 2, 3, 2, 3, 2, 3, and so on. can be written as, so there's 2 and 3, two numbers, so it becomes 23 over 99. Again, I would encourage you to play around a little bit with your calculator when it comes to this topic. So try some different fractions. Let's say just 23 over 99. You can check me if it actually works or not. Try. What if you type 999? What happens? So this is what's going to happen. So let's just take a look at this quickly. How do we actually figure this out? So the first one is quite easy. By analogy with this, so 0.43 repeating becomes 43 over 99. And that's it. Okay, so here also be careful. Sometimes it can be simplified. Not in this case, 43 over 99 cannot be simplified, but sometimes it can be simplified. Okay, next one is a bit more interesting. So number two, 0.617. Please notice that 6 is not repeating, it's not recurring. So only 17 part is recurring. So it's going to be like this: 17, 17, 17, 17. So one of the methods you could use is you could separate the repeating part from non-repeating part. So we could write this like this. We could write it as 0.6 not repeating part plus 0.017. So that's the repeating part. So this goes here and the rest goes here. Okay, so now that we have this, we can convert the repeating part to a fraction. So let's do this. I think I'm gonna move it down a bit. So 0.017 repeating is quite similar actually to 0.17 repeating, but this number is divided by 10. You see, it would be 0.17 repeating, but we move the point here one step. It means it was divided by 10. So 0.17 repeating can be written as 17 over 99. But if we divide it by 10, it becomes 17 over 990. So this number altogether becomes 0.6 is 6 over 10, and then we have 17 over 990. Now you just have to add them together. So we can times this side by 99. What we're gonna get? 6 times 99 is equal to 594. So that's going to be 594 plus 17 over 990. So the final answer is going to be, what's it going to be? 611 over 990. Again, please watch out. Sometimes it can be simplified. To check if it can be simplified or not, again, you can just go to your calculator. Just type it 611 over 990. Oh, sorry, 990. So this cannot be, whoops. No, this cannot be simplified. And the number, actually, this is also how you check it. So you see in calculator, when you type it, that's the number you get. It means you got it right. Okay, so that's it for recurring decimals. I hope it makes sense to you. Let's go to exam style questions. First of all, okay, so first question is interesting. It tells you calculate, but it doesn't tell you show your working. So you know what you can do? Just pull up your calculator and do it. 60.2 divided by 7. Why not? So 60.2 divided by 7. 8.6, that's it. Because again, they don't mention show your working. If they would mention it, you would have to do it like this. You would have to show your working a little bit. If it's a division, you would have to show how do you divide it. It would have to be something like this, 602 divided by 70. You can write it and use your favorite division method, the one that you like, the answer again would be this, 8.6. But again, they don't tell you show your working, so you can just use calculator. That's it. Okay, that's for this one. Next, arrange the following numbers in order, starting with the smallest. Here, normally all the numbers will be converted to decimals. And again, we already have, so 1, 2, 3, 4, 4 numbers, so decimals. So it means we have to convert the rest of them. So this fraction, percentage, and another fraction, let's convert them to decimals, so that if all numbers are decimals, we can compare them properly. Because if they are like this, if they are fractions and decimals, it's hard to compare them. So we have to convert them all to the same values. Let's do that. So 1 over 5 becomes 0.2. Again, you can just use a calculator here. So 1 over 5, let's do this together. Where was this button? Here, yeah, 1 over 5 becomes 0.2. So that's it. 0.6 stays like that. Percentages, 25%. As you probably know, percentage is just another fraction with denominator of 100. So that's 25 over 100, which becomes 0.25. And finally, this one, 13 over 48. So let's do this. 13 over 48 becomes 0.2708, and then 3 repeating, 0.2708, and 3 repeating like this. Now we can just take a look at them and compare these numbers. Okay, starting with the smallest number here would be 1 over 5, or 0.2. So that's the smallest one. Oh, actually, sorry, no. I was not being careful. This is the smallest number, 0.1348. That's the smallest one. You see, pay attention. I just almost skipped the right answer. Okay, so this is the next one. Next one is 1 over 5. It's the second smallest. Then we have 0.21. Then we have 0.25%, 25% or 0.25. Then we have 13 over 48. Then finally we have 0.56 and 0.6 will be the biggest, the largest number. Here again, try to be careful when you arrange them, especially with decimals, 0.56 and 0.6. It may seem that 0.6 is smaller, but actually it's not. Actually 0.6 is larger than 0.56 because it can be written as 0.60. That's the way decimals work. So because it can be 60. So it's larger. Okay, next question. This is about fractions. Quite an interesting question, I think. We can do it step by step. So 1 plus 2 over 4 plus. So here, of course, we have to try and probably have to start from here. So 16 plus 32 is going to be equal to 48. So we can have 8 over 48. This actually can be just typed in the calculator as well. But okay, so let's do this like this first. Then we will check it with calculator. So it's going to be 1 plus 4 plus 8 over 48. It's going to be 4 and 1 over 6. So it's going to be 1 plus 2. We can say divided by 4 and 1 over 6. Because again, this fraction sign can become a division. So what we gonna get? We're gonna get 1 plus 2. 4 and 1 over 6 actually becomes. It's gonna be what's going to be 25 over 6, right? And if you want to multiply it, if you want to do something about it, we have to flip it. So it becomes 2 over 1 times this number flipped times 6 over 25. So that's going to become 1 plus 12 over 25, and the final answer is going to be 1 and 12 over 25. That's it. So again, we did this part first. 16 plus 32 became 48. Then we do 8 over 48 becomes 1 over 6. Then we can add it together. So this becomes 1 over 6. 4 plus 1 over 6, of course, is just 4 and 1, 6, which becomes 25 over 6. And then we can finally finish this. So 1 and 12 over 25. That's it for this one. Oh, again, how to type it in calculator. Let's try to figure this out. So 1 plus, and now we have this crazy fraction. So 2 over 4 plus 8 over 16 plus 32. So we can type it like this. It becomes, it's going to be 1 and 1.48, which is the same as 1 and 12 over 25. Basically the same thing. Okay, that's it for exam. Oh, so this is one more question just to remind you about BODMAS. One more question from past papers. Let's finish on this kind of a fun and easy question. Frankie says 15 minus 3 times 2 equals 24. Frankie is wrong. Explain why. So he is wrong because Frankie forgot about BODMAS. So that's why he is wrong. Because he did, you know what he did? He did the subtraction first. So he did 15 minus 3, which is 12. And then he did 12 times 2, which is 24, which is, of course, wrong. Multiplication comes before the subtraction. So this is brackets indices, division, multiplication, addition, and subtraction. So of course it's not right. First of all, you have to do 3 times 2, which is 6, and then you do 15 minus 6, it actually becomes 9, not 24. So Frankie forgot about BODMAS. Multiplication, you can also write multiplication comes before subtraction. Okay, that's it for fractions, decimals. A couple of past paper questions. A little bit long, but more or less comprehensive as well. So thank you for your attention if you actually watched this.